Hello and good morning to UPSC Fever Science section. So in this chapter, today we are going to see chapter number 7 on mixtures. So you have to click on UPSC and then select Science, and in Science you have to choose chapter number 7, that is on mixtures. Right, so this is a very factual chapter and there are many possible MCQs that can be asked from this chapter. So the introduction of this chapter: homogeneous mixtures and heterogeneous mixtures are the two types of mixtures that are possible. So the mixtures that have a uniform composition throughout, like when we dissolve salt in water or when we dissolve sugar in water, such mixtures have a uniform composition and are called homogeneous mixtures. However, heterogeneous mixtures have non-uniform composition, like dissolving iron filings in salt or iron filings in water. So these are known as heterogeneous mixtures. There are solid solutions like alloys, which is like brass, which is an alloy of zinc and copper. So even such solid solutions are homogeneous, whereas gaseous solutions like air, which is a mixture of nitrogen, oxygen, argon, carbon dioxide and other gases, is also a homogeneous mixture. Suspensions, you can write this: homogeneous mixtures and heterogeneous mixtures. Suspensions are also one of the types of solutions. In these solutions, the solutes, which is the particles that are dissolved, they do not dissolve in the solvent but remain in suspension. So this in chalk powder and water solution, the chalk powder does not dissolve and so it is like a suspension. Then there is one more form of mixture known as colloid. So in colloid, it is a type of heterogeneous mixture and the solutes are very small in size, so not visible to the naked eye, but the mixture appears to be homogeneous. Example: milk. So when we look at milk, it does not look like there is any solute present. However, many small size solutes are present in milk and it is a heterogeneous mixture known as colloid. Right, so colloids have one special property, that they exhibit a effect known as tidal effect. Under this tidal effect, whenever a beam of light passes through that colloid, it is scattered, and so this property is known as tidal effect. There are two components of any colloid. One is that it is a dispersing medium, and this dispersing medium acts like the solvent, and there is a dispersed phase or a dispersed medium which acts as a solute. And the last property of colloids is that by a process of centrifugation, we can separate the solutes and the solvent, which is the dispersed phase and the dispersing medium. Right. So examples of very popular colloids found: one is when the dispersed phase is a liquid and the dispersing medium is a gas, then aerosol is the type of that colloid, and fog, mist, clouds, these are all types of aerosols, and so all of these are also colloids. So you can find this different types of colloids in this chapter: liquid gas, solid gas, gas liquid, liquid liquid, and so on. So you can visit our website and you can see this chapter and it will give you all the details. Moving ahead, suppose you want to separate a solute, multiple solutes that dissolve in a same solvent, like dye or pigments from natural colors or multiple drugs that have been dissolved in blood. So there is a process called chromatography which can do the task. This is especially useful if you are trying to remove various solutes that have been dissolved in a single solvent. Then the last part is distillation and fractional distillation. So distillation is used when two miscible liquids have sufficient difference in their boiling points. That means here a miscible liquid is when the two liquids when added together form a homogeneous solution. So a mixture of sorbitol and glycerol is a example of miscible liquids. There are many other examples where two liquids can be mixed together and they form a homogeneous mixture. So a fractional distillation process is involving boiling that homogeneous mixture and separation of the two liquids. So say glycerol has a boiling point of 100 and sorbitol has a boiling point of 200. So when we perform distillation on their mixture at 100 degrees Celsius, glycerol starts to boil and becomes a vapor, and this vapor is then separated out, and continuous boiling allows the temperature to reach 200. At 200 degrees the other mixture starts boiling, forms a vapor, and then can be separated out. So distillation is done in this way to separate two miscible liquids, but they should have sufficient difference in their boiling points. But if the sufficient difference is not there, and by sufficient difference I mean that the difference in their boiling points is less than 25 Kelvin, then a second procedure called fractional distillation can be performed to separate the two liquids. And fractional distillation is performed to separate the various components of petroleum. Petroleum or crude oil has many various components which have very small difference in their boiling points. So by performing fractional distillation, we can separate out these components. Right, so with that this chapter is over. Certain miscellaneous facts are given, you can note them down. Important alloys: brass, it is an alloy of copper, zinc; bronze is copper and tin; and solder, a very important alloy which is used for welding of electrical wires together. So soldering iron is an example. If you are now confident with this chapter, you can attempt our quiz, and remember to get at least 80% marks if you want to move ahead to the next chapter. Right, so it is a very simple quiz. Thank you for watching this video on mixtures. All the best.